Hello, Professor Simmons here. I'm going to talk to you about concept mapping, which is a technique we use as a study aid to help students see how different parts of a topic that we've been studying fit together, or even how different topics from the course fit together. Students in previous years have found that it clarifies exactly what they did and didn't understand about a topic. You'll work on it in teams during class sessions all the way through the term, and it really generates good discussions about exactly what did that definition mean, and exactly why was it said this way, and how did these two parts of class relate to one another. There is a lot of detail about the principles of concept mapping and some example concept maps elsewhere on the course D2L site. This is just a quick introduction so that you'll be prepared when you start making your first concept maps on the first day of class. Basics, and I'll show you an example in a minute, but basics are that the concepts are shown on a map by circled words. So you place them in different locations on the page, and then you connect them by lines that are labeled and that generally have an arrow for direction. So the lines show the relationship. One concept might imply the other. And so concept A implies concept B. You draw a line with an arrow going from A to B, and the word implies as a label, for example. There are ways of putting in examples. If you just want to give an actual concrete example of a concept, you could put the example next to the concept and draw a little line saying example, and that would be fine. Usually a map is organized so that the most important or most general concepts are either at the top with the less general or less important ones moving down toward the bottom of the page, or I actually prefer to put the most general things or the central organizing concept literally in the center of the page and have things kind of sprout off in different directions. Now, a very strong concept map will include really clear labels defining the relationship between the concepts. That's how we can tell if you really understand what's going on. There should generally be cross-links between a lot of different concepts. That is, the map will come to resemble something a bit more like a net, and not just simply a bunch of spokes radiating out from the center or a linear graph of some kind. You should put in a lot of detail and examples, and there should be an overall sense of unity, a sense of perspective or theme that you're trying to convey. You can't necessarily put everything about a topic into one map, but you should be able to convey your understanding and your perspective on what's really important. On the next slide, we'll look at an example. Here's a draft of a partial concept map of our entire course. It's not complete, but it gives the general idea of how you make a map. So you see I've put the course title as the most general thing at the center, and the different topics of the course are coming off around the center as successive spokes. Here we've got vector calculus, and the relationship line says first topic in the class is vector calculus. Here we have second topic, Fourier series, third topic, ordinary differential equations. And then we're kind of skipping ahead a bit. We've got next to last topic is partial differential equations. The last topic is complex analysis. Now, I haven't really put in any of the details about several of these topics, as you can see. These don't really have any detail coming off yet, but I've filled in a bit of the detail related to ordinary differential equations. And you can see that I've got a bit of a definition. I've got ordinary because it includes only ordinary derivatives, classified by the highest number of derivatives, and then we go and talk about the meaning of first order and second order. Here I've given an example, and here remember there are the labels on the relationship lines that tell exactly when I know this is first order or second order. Then down here we're talking about partial differential equations. I've got a little bit of information here. We've got the definition. It includes partial derivatives, I've got an example, Maxwell's equations. But what I want to stress here is that I've got a topic here, separation of variables, not necessarily a major topic of the course on its own, but it's one that's related to both partial differential equations and ordinary differential equations, in the sense that I say that partial differential equations are solved by separation of variables, which breaks them down into ordinary differential equations. So there's a concept I'm conveying by linking several different other concepts and giving clear relationship labels to the lines that link them. And then separation of variables, we break down into saying that you can do it in terms of Cartesian coordinates, spherical coordinates, and cylindrical coordinates. So these are pieces of information about when you might, different ways of using separation of variables. And then we've got examples of different kinds of equations where those might apply. So this is just a little piece of a concept map of the course, but it indicates the idea of concepts in circles or boxes, linking lines with clear labels showing what the relationship is and the direction of the relationship. The idea that one should have something that comes to look more like a net with loops in it and not just simple branching trees, and then that you should put detail and examples. Finally, I wanted to show you the rubric that we use for grading the maps that teams turn in, so again you get a sense of what we're looking for and what will make the map useful to you as a study tool. I should note that after you turn in the map from your team, you'll be able to see a map that the professors made for the topic and use that as an additional study aid. So when we grade your maps, we look for 4 different things: concepts, connections, complexity, correctness. So we want to make sure that you are representing all of the major topics well and giving good information about each of them. We'll start you off with a list of a number of the major concepts from the particular part of the course, but we'll expect you to add others to fill in the gaps. I can't say enough about how important those connections, those linking lines are. Not only the direction, but the label really tells us what you have understood about how the different concepts fit together. So those are really important. And of course, showing how they form webs of interrelationships among the topics is very important. That's what lets us see that you've got all the nuances of what we've been working on in class. Of course, finally, you do need to have accurate information in there, and we want to see what your team's perspective is on the topic. What things are the most important, requiring the most detail, which connections really are most informative, and we'll be looking for that as well. So these are the things that make a good and effective map that will help you study. And we'll start using this from the very first day of class and all through the term. That's all.